Hello students, today we are going to study about the structure of atom. It means what? How the electron, protons and neutrons are arranged to form an atom. For this, a number of scientists came forward to explain this structure of atom, and they gave models also. First model of structure of atom was given by J.J. Thomson in the year 1898. He said that atoms are spherical in shape. In this, the electrons are embedded inside the positive sphere. So the positive charges surrounds the electrons. He said that the mass of the atom is assumed to be uniformly distributed over the atom. Then came Rutherford. After J.J. Thomson, Rutherford gave his model of atom. He said that Thomson model of atom is not an appropriate explanation of structure of atom, because he has done an experiment, and according to his experiment, this model was not explaining the structure of atom. So he conducted an experiment, and he saw in that the positive charge are embedded, or they are present only in a small space, and the electrons, they are revolving around it. And so he gave his model, and he said that positive charge and the mass of the atom is concentrated in the nucleus, which is very small in size, and the radius of the nucleus is what? 10 to the power minus 15 meter. Then he said that nucleus is surrounded by the electrons that moves around the nucleus with the very high speed, and this he's named it as what? Orbits. Then he said that electrons and nucleus are held together by electrostatic force of attraction. He said that as the nucleus is consisting of positive charge and the electrons, which are negative in charge, is revolving around it, he said that how they are held together? They are held together by the electrostatic forces, because in the nucleus positive charge is present and the negative charges are revolving around it. Now let us discuss the drawback of Rutherford model of atom. He said that yes, the positive charge is present in the nucleus and the electron is present outside the nucleus in the orbit. This electron, it is revolving around the nucleus, and if it is revolving around the nucleus, according to the electromagnetic theory of radiation, Maxwell said that if it is revolving, it will release out energy, and if it releases out energy, naturally the energy will go on decreasing, and a time will come when it will fall into what? The nucleus. But really this doesn't happen. So this theory of Rutherford model of atom was said that yes, it has got the limitation, and this was later on explained by Bohr. Now suppose this nucleus is present and this electron is not revolving around the nucleus. What will happen? This, if it is present in the stationary mode only, what will happen? This positive charge will try to attract this negative charge, and as the result it will go on shrinking, and it will again get into the nucleus of the atom. Next model is the Bohr atomic model. In this, before studying this Bohr's model of atom, we need to know some terms. So first term which we need to know is radiation. So what is radiation? Right now I have said electromagnetic radiation theory, which was given by Maxwell. Okay. Now other terms in which we use radiation, like infrared radiation, ultraviolet radiation. Okay. So what is radiation then? Radiation is the emission or transmission of energy in the form of waves or particles through a medium, like in case of the sound waves, or in vacuum like electromagnetic waves. And here we are concerned with the electromagnetic waves. So in order to explain the structure of atom, Bohr took the electromagnetic waves and made it strike on a matter. Matter is what? Do you remember? It has got mass and it occupies space, and it consists of what? The atoms. From this experiment, he took out the information about, all the information about the structure of atom, and it was nothing, just the improved structure of Rutherford. So what helped him was the characters which of the electromagnetic wave helped him. Which characters? The dual nature of the electromagnetic waves. What do you mean by the dual nature? The wave and the particle nature. And the second was the experimental value of the atomic spectra. This you will study it later in this chapter, so don't panic over here. Now, in order to understand this wave nature of electromagnetic radiation, what we need is you take an object, okay, and you heat it. What will happen? It will either emit or it will absorb the radiation. And this, as this is emitted or absorbed, here heat is used, it is known as thermal radiation. So in the 19th century, scientists tried to find out what this thermal radiation is made up of. So now at present, we know that this thermal radiation is made up of different frequencies and wavelengths. So now some theoretical portion. Okay, first to give the theory of electromagnetic wave was James Maxwell, and experimentally the theory was confirmed by Hertz. Now we are going to study about the Maxwell explanation of electromagnetic waves. He took it at the macro level. Macro means big. Okay. He said about the behavior when the charged bodies interacted with the electrical and the magnetic field. He said that the charged bodies under acceleration, they radiate waves in the form of magnetic field and electric field. And this magnetic and electric fields are transmitted through what? The waves. Okay, and these waves are nothing but the electromagnetic waves or the electromagnetic radiation. Here you can see from the graph, here the direction of the propagation of the wave. In this you can see the magnetic field is in the z-axis and the electrical field is in the y-axis. Both magnetic field and electric field are moving perpendicular to each other in the same direction. Okay, here I am talking about the z-axis. Actually, better you all have studied about the x-axis and y-axis. So this z-axis, here we can see it is a three-dimensional actually figure. Okay, you can see now this is what the z-axis. Okay, so here you can see magnetic field is in the z-axis and the electrical field is in the y-axis, and they are propagating in the same direction, but they are perpendicular to each other. Now let us study the characteristic features of the electromagnetic waves. Okay, what characteristic features does this electromagnetic waves have? First feature is that this electric and magnetic field, they are perpendicular to each other and also to the direction of the waves. They can travel in vacuum, they don't need any medium to travel. And third characteristic features are there are a number of electromagnetic radiations which vary, which has differences with each other by what? The lambda and the frequency. Lambda means what? The wavelength. Okay, and this constitute the electromagnetic spectrum, which I said to you we will start studying later. And there are different kinds of units. Naturally here we have seen here they vary from each other, so naturally they will have different kinds of units, and the units used in the electromagnetic radiations are, first it has been written over here is the wavelength, which is denoted by small m, and this is meter. Then next is the frequency. Frequency is denoted by its unit is hertz and it is represented as per second. So next is velocity, whose unit is meter per second, and here the velocity of electromagnetic waves is equal to the speed of light. So it becomes what? 3 into 10 to the power 8 meter per second. Next is the wave number. It is represented as 1 upon lambda, that is 1 upon wavelength, and so here it becomes what? Meter inverse. This is all for today. Next in the next class. Take care.